Let's discuss common data question 48 and 49 from test 10. This is from strength of materials. So hollow cylindrical drum of 600 mm diameter. So diameter is 600 mm, has a thickness 10 mm. So this is a thin pressure vessel. The drum is subjected to an internal pressure of 3 MPa, Newton per mm square is 3 MPa. And the Poisson ratio is given as 0.32. I am just denoting by nu. And Young's modulus is 2 into 10 power 5 MPa, Newton per mm square. I am writing MPa. Okay, so this is a thin pressure vessel, and the formula for your circumferential stress or the hoop stress is PD by 2T, and the longitudinal stress is PD by 4T. So what is asked in the 48th bit is the longitudinal stress, which is PD by 4T. So let's calculate. Pressure is given as 3 MPa, diameter is 600 by 4 into T. So this comes out to be 3 into 60 by 4. That is nothing but 15 3 is 45. So it is 45 MPa. So this is a straightforward application of formula. Answer for 48 is A, 45 MPa. Now 49th, what is asked is the volumetric strain. Now for this we need to see. Now volume for a cylindrical vessel is pi d square. For a cylindrical shaped body, the formula for a cylindrical body, forget about it's a thin pressure vessel or not. For a cylindrical body, it's pi d square L. So volumetric strain is given as diameter 2 times the diameter strain plus the length, the strain in the length direction. Well, this can be seen. Well, if you take a delta V, and if you write here, if you just write V plus delta V as pi d plus small change in the diameter whole square into L plus delta L, and then you expand, you will get d square plus delta d whole square plus 2d delta d into length plus delta L. So now we take only the first order. If there is a multiplication of two delta terms, we neglect that. So you get pi d square L as one term, then pi d square L, delta L as one term, and then there is another term called pi 2d delta d into L. The remaining terms are ordered of 2s, which we neglect. So I am just deriving this formula, and now pi d square L is V, so it gets cancelled out. So delta V is pi d square delta L plus pi 2d L delta d. Now if I divide with V, which is pi d square L, so I will get, so V is pi d square L, so if I divide with this, I will get delta L per L plus delta d by d twice, and this is volumetric strain. So that is what is asked, the volumetric strain. So that is nothing but delta d by d. So that is nothing but circumferential strain plus the length strain. Now circumferential strain is given as your, well, if you just recall, now this is your circumferential stress PD by 2T, and this is your longitudinal stress. Now circumferential strain would be sigma C by E minus nu sigma L by E. Okay, and the longitudinal strain would be longitudinal stress by E minus, so this is modified Hooke's law. I'm just using the modified Hooke's law. So if I substitute this, I'll get sigma as 2 sigma C. So sigma C is, so E epsilon I am getting on, so it's PD by 2T minus nu PD by 4T plus it is sigma L, so 1 by E, sigma L is PD by 4T minus PD by 2T nu is 1 by mu, so this is 1 by E. So now if I take out, so now it's all question of substitution, so and the values are given. So once I substitute this, remember PD by 2T, when PD by 4T is 45, so PD by 2T will be 90, so 90 minus 45 plus 1 by E, 90 minus 45 into nu is 0.32, So if I simplify this and multiply with E value, I'll get 8.55 into 10 power minus 4. Remember, it doesn't have any units because it's just a strain length per length. So the answer for this is B. So remember that you have to use, for the volumetric strain calculation, you have to do all this. It's 2 times the diametral strain plus the longitudinal strain, and diametral strain you have to always use the modified Hooke's law when you have a multi-axial state of stress. So the answer for 48 is A, answer for 49 is B. Thank you.